Good day, boys and girls. Today we are going to do technical mathematics. Under technical mathematics, we'll be looking at finance or financial mathematics. By the way, my name is Mr. Posa. Now, before we can start with our lesson for today, I want to advise you that you should get an examination guideline from DBE website. Is very important document one should have because it's going to help you a lot. It outlines the important information that you need to know about each topic, things that you need to know before you can go and write your trial exam or the final examination. Okay, now let me take you through the finance and see what we're having. All right, under content, we have break down the financial mathematics. First, we have use simple and compound growth and decay formulae. And then we go to straight line depreciation and depreciation on reducing balance method. And the last one is nominal and effective interest rate. Now, I know this is a topic that we have dealt with last year in grade 11, but it's going to be part of the exam that we're going to write for trial exam as well as the final exam. So it's very important for one to revise the financial mathematics. So today I'm going to take you through all these subtopics that you see on the screen. All right. Now let us get started and see what we are having. The introduction, simple and compounded growth and decay. And now we are going to start with the simple interest. Now, as you can see, we are having a formula for simple interest, which is A equals to P into 1 plus IN, right? Then for A, we know it's a final amount, or you can say it's a future amount or the accumulated amount. That is for A. And then as for P, it's a present amount or the starting value. And then I is interest rate in terms of percentage. Then remember, when you are dealing with I, and then you have to calculate, if you are given I, that I you always divide it with 100. Now, N is the number of time period, right? Now let us get example where we are going to apply the formula for simple interest. The first question that we might get, it says, if an investment, let me just take my pen. Let me take my pen. If the investment of what, 8,000 earns the 12% simple interest, you can see simple interest, meaning in this case, we are going to use the simple interest formula. Determine the value of the investment after 5 years. The money of investment after 5 years, meaning we want to know after 5 years, how much money are we going to accumulate, which is the value of A. Then in this case, we'll be calculating what? The value of A. Now let's see how do you go about it. First, we are going to write your formula for simple interest. And then it's very important every time when you read your scenario and write the data, meaning you write what we have, and then so that you can be able to see what are you going to calculate. You can see from this scenario, this 8,000 is the money which is invested. It means you invest it now, meaning that is going to it's going to be what? The present value. I, you can see I is 12%, and then N, number of time period, which is 5 years, right? Then we're going to substitute that You can see where you see P, then you just substitute with 80,000, and then I 0.12. Remember, I you always divide by 100, then times 5. Then the answer that we're going to get is what? Is 12,800. So that is the amount of money that we're going to get after five years. Okay. The next question says, determine the simple interest rate. If the investment of 20,000 is worth 30,800 after 3 years. Now, when you read this scenario, you can see that we are in need of I this time. We are in need of I, which is the interest rate. And then between 20,000 and 30,800, you must be able to see which one is A and which one is P. Now, you know, every time when we are dealing with you are investing an amount of money for a certain time period, then the present value is always lesser than the future value, because the future value is it comes with what? It comes with the interest, right? So it's always much more than the present value. Now, let's see. You first write the formula, because since you're in need of I, then you should we have A and P. Then you can see your A is 30,800 equals to 20,000. And then I mean the number of years, which is 3I, because we are calculating for I, the interest rate. Then the third step, you are going to divide both sides by 20,000, right? Then we will be left with what? 1 plus 3I. Then we're going to do what? Transpose this positive 1 to the right hand side. Then remember, it's going to be negative what? Negative 1. Then we're going to say 30,800 divided by 20,000 minus 1. Then you're going to obtain what? 1,54. Thereafter, you're going to divide both sides by 3. Then you're going to obtain 0,513333, right? But because we have to leave our answer in terms of percentage, then you're going to multiply by 100, then you're going to have 51%. So that's how you should answer this question. So we're using what? The simple interest formula, right? Now let's proceed. We are now looking for compound growth. Then we're having a formula for compound growth. A equals to P into 1 plus I to the power of N. So that is the formula. Then S for A is the same, final amount, P present amount, I is the interest rate, and N is the number of time periods. So it's still the same, all right? But remember, the simple interest formula and the compound interest, they differ. You can see in this case, the N is now exponent, right? The number of time period is exponent in this case. Now, before we can proceed in terms of getting the example where we're going to use the compound interest, we have to emphasize this issue here, which is the different compound periods, because we are going to use them. The first one is, say, monthly, we have 12. Why 12? Because in a year, how many months do we have? We have 12 months, right? So under compound interest, we are going to be dealing with compound periods, all right? You can get compound monthly, it will differ. Now, the other one that we're having is weekly. Then we have how many weeks in a year? 30, 50, 52. And then we have daily. How many days we have? We have 365 days in a year. And then semi-annually, or sometimes they can call it half yearly. So it's 2, right? Half of a year. So the first 6 months and the second 6 months. So how many 6 months do we have? We have 2, all right? And then quarterly, we have 4. And then annually is 1, right? So please, every time when we are going to calculate using the compound interest, you must always remember monthly, weekly, daily, semi-annually, quarterly, and annually. So all these things you must be able to know every time when you have to answer questions under compound growth. All right. So we are going to be calculating using all these different types of compound interest, right? So make sure you know them by the time we're going to calculate. All right, let's proceed. Example 1 from the compound growth. All right, let us first read the first scenario. If Jane wishes to invest, wishes to have what? 120,000 in 5 years' time. This person wished to have this amount of 120,000 after 5 years, which is the value of A. He wants to have this. He wants to accumulate 120,000 after 5 years. How much money she invests if she's guaranteed a return of 8.5% per annum compounded what? Compounded monthly. Remember, previous slide we talked about the monthly. We're going to use 12, but we're going to see how do we go about using that 12, right? Now, let's see how do we answer this question. You first going to write the formula, and then it is very advisable every time when you read your scenario, you write your data, write what do we have so that you can be able to see what you are calculating, right? Or what is needed. Now, in this case, we can see that this 120,000 is going to be our A. You can see this is A, and then this is N, and then it says how much money she invests, meaning we are looking for P in this case, right? We are looking for P. Now you can see that value of 820,000 a P, and then now we are having the interest rate of 8.5. Remember, I said you always divide it with what? 100. Now, after dividing with 100, then we're going to obtain 0.085. Now, the compound period in this case is monthly, and we said monthly is 12. Then how are we going to treat that 12? We are going to divide it. We are going to divide the interest rate with 12 and then multiply the number of years with that 12. All right, always don't forget that you divide I with the interest rate with compound period, and in this case is 12. Then you also want to multiply the number of years with that 12. Then the third step, what we're going to do, we're going to divide both sides by this bracket here. This is the whole bracket. We're going to divide so that we can be left with P. And then after reaching the third step, you just press the calculator, you press everything that you see on the screen, then you will get the answer. And our value of P is 78,569.99. So that is the value of A. So this is the amount Jane she must invest in order to accumulate 120,000 after 5 years. All right. Now the second scenario, say Tebo wishes to have 25,000 in his bank account in 5 years. If the interest is compounded now semi-annually, and he is invest 13,760. What is the interest rate he required to fulfill his wishes? What is the interest rate? Meaning in this case, we are going to calculate the interest rate I. All right. And let's see how do you go about it. Now, second step, you substitute, the value of A is always greater than P because the amount of money that we're going to get after 5 years come with what? Come with the interest. Now this is 25,000 and P it's 13,760 plus 1 plus I to the power of 10, right? Then the third step, we are going to divide both sides by 13,760. Now, because we are in need of I, and then we've got an exponent there, which is 10. Now we need to get rid of this 10 here. But how are we going to get rid of this 10? We're going to multiply this 10 by 1/10. And then what we did on the left-hand side, we must also do on the right-hand side. You can see that we also multiply this exponent up there with 1/10. Then the next step, now we are no longer having what this 10 here, because 10 multiplied by 1/10 it gives us 1. So we are having 1 plus I equals to this number here. And because we are calculating for I, then we are going to transpose this positive 1 to the right hand side. Then obviously it's going to change the sign. Remember, when you transpose. And then here we did it. And then after we have minus with 1, then we're going to get 0,067 152971931. Done. Since we have to calculate the percentage, then we have to multiply with 100. Then our percentage now is 6,7%. All right, it's 6,7%. So that's how you should calculate interest rate under compound interest. I hope it makes sense. It's very interesting. Let's proceed. Now we're having example 2, again under compound growth. We're still under compound interest. Let's see the scenario that we will get. It says 2,850 is invested at 8% per annum compounded quarterly. Quarterly is very important. It's very important. We are dealing with quarterly for 15 years. But after 9 years, the interest rate changes to 10.5% per annum compounded monthly. How much is the investment worth after 15 years? Now you can see from our scenario now, we are now having what? 2 interest rates. We have to calculate using 2 interest rates. But the question is, how are we going to calculate that when we are having what? 2 interest rate? Even the compounded period, they differ. We have quarterly, we have monthly as well. So how are we going to do that? Let's see the solution. First, we say use the timeline to answer this question. So using of timeline is going to help us to answer this kind of a question. The timeline, always when we have more than 1 interest rate, it is very advisable to use timeline. Now we are going to learn on how do we use timeline. You draw your timeline, then you put the number of years from T0 to T15 there. You can see, because the total number of years is 15 years. So we are going to end with what? With T15. Okay. And then we have the amount that it was invested, which is 2,850. Okay. Now let us go to our scenario and study it again. It said this amount of money is invested at 8% per annum compounded quarterly for 15 years. After 9 years, the interest rate changes, meaning from the first year until the 9th year here, the interest rate for this period is 8%. Is 8%. Then after 9 years, then the interest rate start to change to what? Start to change to become 10. Let me try to write 10 here. 10, what? 10.5%. 10.5%. So now let's see on how do we calculate when we're having such question. All right, and even the compounded period they differ, right? For the first 9 years, we have 8%. Remember, this 8% we're going to divide it with 100, and then we're going to divide with 1. with 4. Why 4? Because you can see that that percentage is compounded quarterly, and we agreed earlier on that for quarterly we are using what? We are using what, 4, right? And you're going to divide this 8,000 after we have divided it with 100. Then you're going to divide with 4 again. And that 4, remember, you're going to multiply the number of years with that 4, right? Now, the same applies with this one of 10,5. Then we're going to divide with 100. Then it says this 10,5 is compounded with monthly. Then we agreed that monthly we're going to use 12. Then we're going to multiply this 10,5 with 12. Okay, now let's see how do you first write your formula for compound, and then that's how you should substitute everything. The P is 2,850. Now this bracket is for first 9 years. Is for the first 9 years, right? First 9 years, because we are having two different interest rate. Now the first interest rate is, we said, is 8,000. Now 8,000 divided by 100, it gives us 0,08. And then compounded quarterly, which we are going to use 4, which is divided by 4. And then 9, remember, first 9 years, right? The interest rate is 8%. So it's 9 times 4, right? Then you open bracket, then you then calculate what? You are now adding what? The remaining interest, or the remaining years with the interest of those years. That the interest that we are having here is 10,5, and then this 10,5 you're going to divide it with 100, then you're going to get what? 0,105. Then it says compounded what? It's compounded monthly. Then we're going to use 12. Then we're going to divide it with 12 and multiply the remaining years with 12. And the remaining years from 9 to 15 is 6 years, right? Is 6 years. Then hence we are having 6 times 12 there. Then you just take your calculator, you press everything as it is, then you're going to get the answer, which is 10,885.95, right? So that is the answer that we are getting after 5 years. So that's how you should calculate when you are having two different interest rate. Okay, now let's proceed. Now we are now into simple and compound decay. Remember, we have dealt with what? Simple and compound growth. Now we are dealing with what? Simple and compound decay. Now let's see. And then we're going to start with the straight line depreciation method. Then this is the formula that we're going to use to calculate using the straight line depreciation. Now it's more or less the same with that one of simple interest, but the only difference there is the sign. Remember that one that we did or we talked about earlier on, it was having a positive here, but this one is now negative. So we call it a straight line depreciation. So every time when you get a scenario where we are going to use the straight line depreciation, they always indicate from the scenario that use the straight line method, or you can say use the straight line depreciation method. Now, and then for A is still the same, for P is still the same, is the principal amount, and I is the interest rate, and the N is the number of time period. So nothing has changed, and we are still having the same A, P, and I, and N, right? Now, let us get example where we are going to use the straight line depreciation. And example, let's see. All right, the first one, it says, how long will it take an investment to have in value if it is depreciated at the rate of 12.5% per annum on a straight line method? On a straight line method. So once you know the formula for straight line method, it's going to be quite simple to calculate this question. Now, what do we need from the question? It says how long. So meaning we're in need of n, right? But the problem is now the value of a and the value of p. Now, since we are dealing with depreciation, now when we are dealing with depreciation, we are dealing with items that they lose value after a certain time. For instance, if you are talking about car, right? Then if you buy a car this year with 10,000 rand, after 5 years, this car is going to depreciate. It's going to lose value. It's no longer going to be 10,000 or more than 10,000, but it's going to be less than that, which means it's going to be less than 10,000. So every time when we are dealing with depreciation, the money depreciates. The present value is much more than the future value. Your P is bigger than what? Future value, or the final value, or the accumulated value. Okay, so now let us study this one so that we can be able to see which one is our A and which one is our P. It say the investment to have in value if it is depreciate, meaning in this case we can write it in this manner. This is the formula we're going to use, and then now look here. They say P is going to be half of what? Half of A, right? P, the investment is going to be half of this one, right? I hope it makes sense. I hope it makes sense. Now let's proceed. After you have substituted down, remember we are calculating for n there, and then we are going to divide both sides by what? We're going to divide with 2x, then we're going to obtain what? 1/2. And then the third step, you're going to transpose this positive 1 to the right hand side because we are calculating for n, and then this is what we're going to have. And thereafter, we're going to divide both sides by negative 0.125. And then we divide with negative first, and then this is what we are having 0.5. Thereafter, the second step, we're going to divide with 0.125 so that we can be left with n. The number of years here is 4 years. So we have calculated what? 4 years, the number of n. All right. Now let's proceed. The next question: if an investment of 95,000 depreciate at what? Depreciate at 6.5% per annum using the straight line method. Determine the value of the investment after what? 3 years. If the investment, this is the investment, the money that we are investing, which is going to be our P. So in this scenario, we'll be calculating what? Then we'll be calculating value of A. And then let's go. We first write the formula there. And the second step, we're going to substitute. You can see our P there is 95,000 and I is 0.065. Don't forget your interest rate, you always divide it with 100. Before you can substitute to our equation there, divide it with 100. Then times n, which our n is 3 years there. And the value that we are looking for is what? Is 76,475. So this is the value that we are getting after 3 years. Okay. Compounded decay. Remember, we are done with simple decay. We are now looking for compound decay. Now, this formula that we're going to use is called reducing balance method. You can see it's much more the same with a compound interest formula. The only difference is the sign. This one is negative, that one it was positive, right? And then we still have the same value of A, which is final amount, present amount, interest rate, and the number of time period. Okay, now let's proceed. Let us get an example where we are going to use the reducing balance method. All right, we have a nice car. You can see the red one. I think this one is the Jeep, all right? Okay, now the first question says a car costing 85,000 depreciate at of 12% per annum for 3 years using the reducing balance. What is nice about this question, they will always tell you which method to use. Remember earlier on, we were dealing with what? Simple decay, right? Which the formula that we're using is called the straight line method. So in every question is going to indicate which method to use. So you must be able to know when it say reducing balance, which formula to use, straight line method, which formula to use. It's very important. Now the question says determine the amount of the car after 3 years. Determine the amount of the car after 3 years. Meaning in this case, we are looking for what? Value of A. Because the car is costing this now. Now, the car is costing 85,000 now, which is P, right? Now, let's see how do you go about it. How do you calculate? You first write the correct formula for reducing balance method. We know which formula that we have to use on that. Then we're going to substitute the value of P, I, and N, right? And then the amount that we're going to determine after that is going to be what? 57,925,012. So you can see the future value is less than the present value because why? The car depreciates. It loses value. So the car loses value, right? Then let's proceed. Then we're having another scenario or question. It says determine the rate of depreciation that will be used if a car depreciates from what? From 120,000 to 63,827, 780 in a period of 5 years on a reducing balance method. Sorry, let me just remove that. Let me remove that. All right, let me highlight it. Reducing balance is very important. And then also, what is important, you will have to write your data. You write what we have so that you can be able to see what are we going to calculate. But it's very clear from the question that we need to determine what the rate, the interest rate, which is I. Then we'll be calculating I. Then let's see how do you go about it. You first write your correct formula for reducing balance. And then the second step, A and P. Remember under reducing balance method or what the straight line method, A is always less than P. P is always bigger than A. So don't forget that. Because once you make a mistake on this one, then you're not going to get everything right. So it's going to be 0 unless you are making the correct formula there. The first step, we're going to divide both sides by 100. Let me see. I think there is a mistake, a terrible mistake on this one. A terrible mistake on this one. But we're going to get the correct answer, don't worry. There is a mistake on that one. You can see that we're supposed to, all right, no, everything is correct. I thought there is a mistake. My bad, sorry. Everything is correct. Actually, we're supposed to divide with what? 120,000, and so what we did here, you can see we divide with 120. Therefore, in this case, we can see we are having what? Exponent 3, and then we have to get rid of this 3. The only way to get rid of this 3 is when you multiply with 1/3, and then what we did from this side, which is the left hand side, we also did on the right hand side, 1/3, you can see. And then the next step, we are now having 1 minus I, because this 3 times 1/3 is 1. And then you take your calculator, you press everything here on the right hand side, and make sure you write everything, every number that you obtain from the calculator there. You only round off when you reach the final answer. Then the second step, we're going to transpose this +1 to the right. Right, let's see. And then this is what we are having. Then because we don't want negative I, we want I, then we're going to divide with that negative what? Negative 1. Then we're having 0.1. Now we have to take it to percentage. Is going to be 19.19%. So this is the correct answer that we got. All right. Let's proceed. Nominal and effective interest rate. Nominal and effective interest rate. We are done with what? Simple interest, compound interest, simple and compound decay, where we are going to use what? We are using the straight line method and reducing balance method. Now we are now going to be focusing on nominal and effective interest rate. Now they are saying the nominal interest rate is the rate that is quoted in the question. The effective interest rate is the equivalent annual interest rate that you will receive once compound has been taken into account. In order to compare the interest rate with the different compound periods, it is often useful to convert what? To convert nominal rate into effective rate. It's very important. Now the nominal rate effective formula, then this is the formula that we're going to use if we want to convert effective rate into nominal or nominal to effective rate. So this is the formula that we must use, right? Now let's see I with EFF. This is effective rate here. So it's effective interest rate, and then this I norm is nominal interest rate. Then M, the number of times here the nominal interest rate is compounded. This M does not stand for number of years. It's not for number of years. It's compounded period. So any compounded period that we are going to have, that's where we're going to substitute it there where you see M. Remember, we also talked about the compound period. We had compounded what? Monthly, compounded weekly, compounded quarterly, compounded semi-annually. They sometimes call it half yearly, right? And the other one is compounded annually, right? So you must be able to know those things. When they say quarterly, how much do we going to use? When you say weekly, how much for weekly? Compounded semi-annually is how much? So you must be able to know all those periods about compounded period. Okay. Now let's get example where we are going to use nominal and effective interest rate. The first question say convert the interest rate of 15% per annum compounded what? Monthly to an effective interest rate. Let's see. We write the correct formula. Now you can see from the question that we have to calculate the effective interest rate, and that this is what we are calculating right now. So the second step, we are going to substitute. Remember, you always, even on this aspect, that 15% we divided by 100, right? Here you can see it's 15,15, and then it's say compounded monthly is 12. Then we're going to divide with 12, and then also is going to be 12. We don't have a number of years here, so we only use what? The compounded period. Thereafter, you can see the third step, we're going to transpose this positive 1 to the right hand side. It's what we did, and therefore you take everything, you can press everything that you see on the screen and to your calculator there, and then answer that we're going to have is 0.1608, because we want to, in terms of percentages, then it's going to be 16,08. So that's how you should calculate the effective interest rate. Second question, convert an interest rate of 8.25% per annum compounded quarterly. Now it's compounded quarterly, then we're going to use what? 4 to an effective interest rate. Then you write the correct formula. We are in need of this effective interest rate. Then you substitute, you divide this 8.25 with 100. Then you're going to give us 0.0825. Remember, the compound period is what? Is quarterly. Then you're going to use what? 4. And then the second step, you transpose that positive 1 to the right hand side. Then you press everything on your calculator. You multiply by 100. And the interest rate that we're getting is 8.51. So that's how you should go about it. Okay. So that's how you calculate the nominal and effective interest rate. It's quite simple. You just have to know the formula, the correct formula for that, and be able to transpose where you have to transpose. Okay. Now, all right. Thank you very much for being with me on this lesson. Then we have activity. You can take this activity and try to answer these questions so that you can be able to test yourself as whether you understood the financial or the points that we discussed since we have started this lesson. All right, my dear learners, this is a message for you for today's lesson. It says our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. So please don't give up, always try. No matter how hard it is, you must always push and push and push. Just one more time. I thank you.